You know that feeling, right? You're staring at a blank screen, that cursor is just blinking mockingly at you, and you're sitting there wondering exactly how you're supposed to turn a massive, complex, real-world problem into clean, perfectly working Delphi code. Look, it's a completely universal programmer experience, and honestly, it can be incredibly frustrating. But welcome back, focus learners, to another explainer. Today, we are taking on a genuinely fantastic subject. We're going to take all that abstract coding syntax and transform it into a tangible, highly practical logic toolkit. We're literally building your programmer's toolkit from the absolute ground up, giving you the exact tools you need so you never have to fear that blinking cursor again.
Here is our step-by-step roadmap for today's explainer. We'll start with variables and core calculations, move into making basic code decisions, then navigating complex conditional logic, followed by building step-by-step algorithms, and we'll wrap up the whole shebang with some essential exam success tips.
All right, Section 1, Variables and Core Calculations. This is all about understanding the essential building blocks of our data.
Okay, let's dive into this. When you're writing a program, you really have to think strategically about where your data actually lives. It's not just about storing a number, it's about who has access to it. Think of a global variable like a giant billboard right in the center of town. Everyone can see it. Now that's super useful if, say, multiple buttons or procedures across your app need to read that exact same total score counter. But here's the catch. Because everyone can see it, anyone can potentially walk up and spray paint over it, which makes it pretty dangerous if you aren't careful with your code. On the flip side, a local variable is way more private. It's like a little sticky note sitting right on your personal desk. It only works inside one specific procedure. You use it when you just need to, jot down two numbers for a really quick calculation, and then that sticky note basically gets thrown away in the trash at the end of the day. The absolute best practice in programming, those sticky notes, your local variables, should absolutely be your go-to whenever possible. They keep your code incredibly clean, and they totally prevent unexpected bugs from other parts of your program coming in and messing with your delicate data.
Moving on to calculations, there is a massive stumbling block that catches so many programmers off guard, and it comes down to understanding two specific operators, div and mod. Listen, these aren't your standard division buttons on a regular calculator. This brilliantly illustrates how computers handle division differently than we do. Think of packing 17 books into shipping boxes, right? And let's say each box only holds exactly 5 books. Div gives you the whole number quotient. It is simply the number of boxes you can safely tape shut and ship off. So, 17 div5 gives you exactly 3 full boxes. Boom, done. But wait, what about the leftovers? That is exactly where mod comes in. Mod strictly gives you the remainder. It represents those 2 sad leftover books just sitting on your living room floor because they couldn't make a full box of 5. So, 17 mod 5 gives you 2. Really taking the time to fully grasp this exact difference between the shipped boxes, div, and the leftovers, mod, is going to unlock so many complex algorithms for you later on. It's a real game changer.
Section 2, Making Basic Code Decisions. Let's look at how we actually translate everyday English into hard computer logic.
So, you know how real-world programming problems are almost always handed to you in these big, standard English paragraphs? Well, computers are incredibly literal. They absolutely cannot read between the lines, and they certainly can't guess what your teacher or client meant to say. But here's the secret. Hiding inside those everyday English sentences are signal words. Think of them as detective clues that tell you exactly what kind of conditional structure you need to map out. If you're reading a prompt and you see phrases like check whether or only when, your program is looking for a simple single condition. But the very moment you read words like otherwise or if not, boom, you instantly know your code has to explicitly handle an alternative outcome. Reading these English signal words and literally mapping out on paper, okay, what happens if yes and what happens if no, before you even type a single line of code, that is literally half the battle.
Let's put these two fundamental structures head to head based on those signal words. A basic if statement is kind of like walking past a bakery on the street. If you're hungry, which is our condition here, you go in. But what if you're not hungry? You just keep walking straight. The code just skips the bakery entirely and does nothing else. For example, if a student's mark is greater than or equal to 50, then show the message pass. If they got a 40, literally nothing happens. The program just moves on. But an if-then-else statement, that is a literal fork in the road. You must turn left to the adult section, or you must turn right to the minor section. There is absolutely no middle ground. If age is greater than or equal to 18, show adult, else show minor. One distinct thing happens if the condition evaluates to true, and a completely different thing happens if it's false.
Section 3. Navigating complex conditional logic. This is where we start layering our decisions for actual real-world scenarios.
Now, real life rarely has just one simple rule, right? Often you have to check multiple conditions all at the exact same time. You're going to use the AND operator when both conditions absolutely positively must be true. Think of it as needing a passport and a boarding pass to get on an international flight. Just showing up with one of them isn't going to get you on that plane. In code, if passing a strict class means your mark is 50 or above and your attendance is 80 or above, failing either one of those checks means you fail the whole thing. Now compare that to the OR operator. You use OR when only one condition needs to be true. It's like asking a friend if they want tea or coffee. A yes to either one completely satisfies the question. To trigger a weekend message in your app, the day can be Saturday or the day can be Sunday. The signal words to hunt for here are both, together, or must also for the AND operator versus either, or one of for the OR operator.
But what happens when one decision entirely depends on the outcome of another? That, my friends, is a nested IF. The logic flow here is like a literal sequence of doors in a long hallway. First, you walk up and check if the person's age is 18 or older. If that's true, you open that first door, step inside, and then ask the next question, do they have a driver's license? But what if that first door, being 18, is locked? Well, the program doesn't even bother walking down the hallway to check the driver's license door. It just turns around and walks away. It's a strictly dependent chain of decisions. You absolutely must pass that outer check before the inner check even matters to the computer. Now imagine you have a whole bunch of exact values to check, like all 7 days of the week. Writing 7 different if statements to check every single day creates what programmers lovingly refer to as spaghetti code, just a massive, tangled, unreadable mess of logic. Instead, we use a case statement. You use an if-else for dynamic true or false outcomes, like checking if a number is greater than 100. But a case statement, it acts like a clean, highly organized post office sorting facility. You use it when you need to compare one single variable against many exact, fixed values. One package comes down the conveyor belt, and it's instantly routed to exact box 1 for Monday, box 2 for Tuesday, and so on. It is such a beautifully clean way to route your code when you have a set list of specific, rigid choices.
So, the crucial point is, you really need to know when to use which tool. Here is your ultimate mental cheat sheet for conditional logic. Knowing exactly which tool to pull from your kit is the secret to fast, efficient programming. One condition only, reach for if. 2 distinct outcomes, if, else. A decision dependent inside another decision, nested if. Both conditions absolutely needed, and. Only one needed to pass, or. And one variable with many exact fixed values, use that beautifully organized case statement. Seriously, keep this logic table memorized whenever you read a new problem description. It will save you so much time. Section 4. Building step-by-step algorithms. It's time to start stringing all these logic blocks together into full recipes. An algorithm, at its core, is simply a step-by-step solution to a problem. But think about baking a cake for a second. If you try to put the icing on the pan before you bake the batter, you're going to get an absolute disaster. An algorithm is the exact same way. It is not just about having the right mathematical instructions, it is about having the right instructions in the exact, unchangeable, logical order. Order is absolutely everything.
A truly great algorithm is grounded in practical math, and you really need to understand why the math looks the way it does in Delphi. Let's look at some real-world formulas. To build an algorithm to find an average, you first need to calculate a running total, and then only after you have that, you divide it by the count of items. What about applying taxes? Calculating VAT isn't just knowing the math concept, it's telling the computer specifically to handle the calculation of taking the price, multiplying it by 0.15 first, and then deliberately adding that value back to the original price before storing the new total. Or applying a 10% discount. Price multiplied by 0.10, and then you explicitly subtract that amount. These fundamental algorithmic formulas are the foundational recipes you'll be using constantly in your toolkit. Now, let's combine those formulas with the conditional logic we just learned. How does a computer actually know if a number is even? Well, it uses that mod operator we talked about, the leftover checker. If a number mod 2 equals exactly 0, meaning you divided it by 2 and there is 0 remainder whatsoever, then boom, it's even. If there's any remainder at all, it's odd. Or what about checking for a perfect square? This is super clever. Take the number 9. Its square root is exactly 3.0. The truncated whole number version of that is just 3. Since 3.0 equals 3 exactly, the computer instantly knows 9 is a perfect square. But try with the number 10. The square root has a bunch of decimals, right? So it will not perfectly match the truncated whole number,
meaning it completely fails the check. It's like a neat little magic trick the computer does.
Okay, let's slow the pace down for a second to walk through a very specific, incredibly common algorithm, swapping values. Imagine you have a cup of coffee, which is variable A, and a cup of tea, which is variable B. You want to completely swap the contents of the cups. Well, you obviously can't just pour the tea into the coffee cup without spilling it everywhere and ruining both drinks. You need a third, empty cup, and that is your temp variable. Step 1, you pour the coffee from cup A into the empty temp cup for safekeeping. Step 2, now that cup A is empty, you can safely pour the tea from B into A. Step 3, finally, you pour that safely stored coffee from the temp cup into cup B. And just like that, following those 3 exact steps, the variables are perfectly swapped without losing a single drop of data.
Section 5, Essential Exam Success Tips. Let's talk about applying this toolkit when you're actually under pressure.
When you finally sit down for your practical exam, I need you to remember that your mindset is everything. First things first, physically take your pen and underline the inputs, the calculations, and the exact outputs required in the prompt. Second, actively hunt for those keywords we talked about, words like and, or, and otherwise. Count the decisions. Third, and honestly, I cannot stress this enough, always validate your inputs. You absolutely must do this because users will inevitably try to type the word 5 spelled out instead of typing the number 5, and it will instantly crash your beautiful program. Fourth, rely on those local variables, your sticky notes, wherever possible to keep your logic clean. And finally, just practice the big 3, mod, div, and your if statements. They are the absolute engine of Delphi practicals. Master those and you're golden.
Before we wrap up, I want to leave you with a quick challenge to really test your new logic toolkit. Imagine a store offers a 10% discount on weekends, but only for students who are over 18. Look really closely at that English phrase. Which exact combination of and, or, and nested ifs would you reach for first to build that algorithm? Take a beat to really think about those signal words we covered. Keep practicing, trust your brand new logic toolkit to guide you through any problem, and I'll see you in the next explainer.